All right, guys, I want to start going over some table problems. Of the ones the first one I assigned you was 2018, number 4, where you're given this table and you're told that it's the height of a tree at time t, it's given by a twice differentiable function, where h of t is measured in meters and t is measured in years. Here's your table. Okay, so again, they can ask you a bunch of different stuff to do on these table problems, which is why they're kind of like a nice little buffet of calculus in one problem. Okay, so the first thing they asked you to do is estimate h prime of 6. Okay, so there's no way we can actually get h prime of 6 because we don't have an h equation to take the derivative of. But again, if they want us to estimate it, this might not be something we've really done. Okay, so but again, keeping in mind what derivative is, the derivative is slope. So we're just going to have to do a slope since we can't do the slope of the tangent line, which is the actual derivative. Remember, we estimate with the slope of the secant line. So the slope of a secant line is the slope between 2 points. So all we're going to do is pick the two above and below points right here. We're going to use 5 and 7 because 6 falls right in between. And we're just going to find the slope between those 2 points. So 11 minus 6 over 7 minus 5. Okay, here you just get 5 over 2. Right? Again, you don't actually have to do the math. Remember, you could leave it as that. Okay? Now, again, in using correct units, interpret the meaning in the context of this problem. So again, our change in y is change in meters. Our change in x is change in years. So there's my units, right? So we know it's meters per year. Okay, and so what this would be, again, if h is the height of a tree, this is the rate of change in the height of the tree at t equals 6. Again, it's an estimated rate of change in the height of the tree at t equals 6. Okay? All right, so anytime they ask you to estimate a derivative, that's it. You just find the slope between two close points that your point would fall in between. Okay, then we go on to read part B of this problem. Now, what part B of this problem is, explain why there must be at least one time in between 2 and 10 such that h prime of t equals 2. Well, if you're unsure, this wording, remember, they're not asking you to find the time. They're just asking you to explain why there must be a time. So remember that whole wording of, is there a time? Why is there a time? That's all theorems, right? So again, typically the two theorems that come up in these types of problem are either going to be IVT or MVT, okay? How you can tell is they want us to show that h prime equals 2. We'll look back. I have a table of h's. So it's not asking me about what I have, it's asking me about the derivative of what I have. So that is MVT. So remember, for MVT, we just have to show that somewhere in this interval, the slope equals 2. So if I look at the ends of the interval, if I find the slope between 2 and 10, that's not equal to 2. So that means I'm just going to have to bounce around, and I'm going to have to find a place where I can see that the slope would equal 2, right? And it looks like pretty easy. It's right here in between these 2 points, right? Because do you see, if I do the change in y here is 4, the change in x is 2. So I definitely know that in between 3 and 5, the derivative has to equal 2 because the slope between 3 and 5 has to equal 2. So remember, our explanation for that would be, now, going back to what the conditions for MVT are, okay? Our conditions are that it must be continuous and differentiable. Again, I don't have an equation. How do I know based on this table? Well, if you go back up to the givens, that's why they tell you it is a twice differentiable function, okay? So that you could use it to explain your theorem. So you could say, since h of t is continuous and differentiable, MVT guarantees, well, actually, let's say, and, let's do the slope, and h of 6 minus h of 3 minus h of 5 over 5 minus 3 equals 2. MVT guarantees that h prime of t equals 2 in the interval 3 to 5. Bam. Okay? So again, mention the conditions, mention the slope, and then make sure you drop the word MVT in there. Okay? Lots of times what you're going to see on these table problems is some sort of Riemann sum. Okay? Like I said, they'll always tell you what to do. In this case, it's a trapezoid with 4 subintervals. Okay? It also says that, and it says, again, it says use a trapezoid sum to approximate the average height of the tree. Now, you'll notice that they threw down that word average. Okay? So remember whenever we see the word average, remember, it's not just an integral, right? So technically, I need the integral from 2 to 10, right? Of whatever I want the average of, which is height, but over the spread, right? So I can rewrite that as 1/8 the integral of h, right? So it's this part that I'm going to use the trapezoid sum to estimate. Because again, I can't do this because I don't have an h equation. But what I can do is estimate this integral. Because remember, that's exactly what a Riemann sum does. It estimates an integral. It doesn't give you the exact area under the curve. It gives you the estimated area under the curve. Okay, so you're given a table of values. Great. The first thing you should notice about your table of values is you do not have equal intervals, which means you are going to have to find the each trapezoid's area separately. Okay, so first thing I would need is this 1/8 is in front regardless. Now, trapezoid formula is 1/2 base 1 plus base 2 times the height. Since every single one of these trapezoid is going to have the 1/2 in front for the area formula, you could also bump out that 1/2, okay? Then what you have on the inside is going to be the area of each of these trapezoids. So for the first trapezoid, right, you have base 1, which is the 1.5, plus base 2, which is the 2, times the height, which is the change in x for that one, which is just 1, plus the second one. Base 1 plus base 2, so that's the 2 and the 6, but the change in x for that one is 2. The next trapezoid, the bases are 6 and 11. The change in x is 2. The next one, the bases are 11 and 15, but the change in x for that one is 3. Okay, if you want, you could have a separate 1/2 in all of these, or like I did, you could bump that 1/2 in front. Again, you don't have to finish the math. That is it. They don't ask us to interpret anything about this because they already told us what it is. It is average height, okay? Then the final problem, okay? The final part D gives you an equation for the height of the tree. So they tell you g of x, which is 100x over 1 plus x, is another equation that could be used to model the height of the tree, where x is diameter, and the height of the tree is in meters still. And it says when the tree is 50 meters tall, the diameter of the base is increasing at a rate of 0.03 meters per year. According to this model, what is the rate of change in the height with respect to time in meters per year at the time when the tree is 50 meters tall? Okay, so if you're uncertain on this one, the wording of this is screaming related rates, okay? So remember with related rates, okay? So what we do with related rates is we take the derivative, okay, with respect to time, right? So, and we know that because they actually said it in the problem. They said, what's the rate of change of height with respect to time? Right now, if I just took a regular derivative of this equation, it would be dg dx. That's not what we want. We want dg dt. So again, that's related rates. So remember, related rates, you take the derivative of the left side. So you take the derivative of g and you get dg dt. You take the derivative of the right side, but every time you take the derivative of an x, you have to follow it with dx dt. You'll also see for this one, we have to use quotient rule. It's not a hard quotient rule, but it's quotient rule nonetheless. So I have low. The derivative of the high is 100 times dx dt, plus the high, which is the 100x, times the derivative of the low, which is just dx dt. all over low squared. Okay? And then all we're going to do is dg dt is what we're looking for. So all we need to do is just substitute in for x and dx dt. Well, they told us dx dt, which dx dt, because x is diameter, this is the change in diameter, which they told us was 0.03. So I'm going to put in 0.03 for all these x's. X in this problem represents diameter. Now, at the instant they want us to do it at, they didn't give us the diameter, they gave us the height of the tree. So I can't put 50 in for X because 50 is the height of the tree. I need the diameter of the tree. Well, how am I going to get the diameter? This is the thing with related rates. If you're missing something in your derivative equation, you could always go back to the original and get it. If you go back to this original gives you an equation with g in terms of x's. Remember, g is the height of the tree. So at this time, I know g is 50, and I could set this equal to 50 and use it to find x. Okay, so in this one, you could cross multiply. So 50 plus 50x equals 100. X, you end up with just x is 1, which is nice on this one after you solve. Okay, so now I know when the height is 50, the diameter is 1. That's what I need for this. This derivative doesn't have g in it at all. It only has x in it. So now all I have to do is just substitute 1 in. For all the x's, I have to substitute 0.03, which they gave me, in for all the dx dt's. And like I said, since it is the AP, we could just stop right there and box it up. But I believe on this one, you do get, I believe this one was 3/4 when you did the math on this. They don't ask you to interpret anything further than that on this problem. So that is done. So again, notice table problem. You got a secant line, you got a theorem, you've got a Riemann sum and a related rates all in the same problem, which is why, in my opinion, this is a likely candidate for your AP, because you can ask a lot of different types of topics throughout the year in one problem. Okay, let's try another.